Okay, so let's answer the problem from the lecture. Show by mathematical induction that 5 raised to n minus 1 is divisible by 4 for all positive integers. So let's first prove that it works for the base case. So the smallest possible positive integer is 1. So let's start with that. So let's substitute 1 to n. So p of 1 is equal to, again, we'll substitute 1 to n. So this will be 5 raised to 1 minus 1. 5 raised to 1 is 5 minus 1, so we'll get 4. And yes, that is divisible by 4. Next. Next, let's substitute 2. So we'll get 5 squared minus 1, and that's equivalent to what? 5 squared is 25 minus 1, so that's 24. Is that divisible by 4? Yes, it is. Divisible by 4. Okay, let's try one more. So next is 3. So let's substitute 3. So we'll get 5 cubed minus 1. 5 cubed is 125 minus 1, so that's 124. And yes, that is divisible by 4. I'm pretty sure it's divisible by 4. So we have proven the base case. So let's go to the next step, which is our inductive hypothesis. Here we assume that it works for any number k. So let's write that. So assume that it works for any number k. So if we put k here, that would be 5 raised to k minus 1. So we assume that it works for any number k, and that means 5 raised to k minus 1 is assumed to be divisible by 4. So after assuming an inductive hypothesis, we assume that it works for any number k. Now, we prove it. We prove that it works for the next number k plus 1 in our inductive step. So prove that it works for any number k and the next number k plus 1. So we have to show p of k plus 1. So if we substitute k plus 1 to n, we'll get 5 raised to k plus 1 minus 1. And we prove that this is divisible by 4. So let's prove it. So what could we do here? Let me just retype 5 raised to k plus 1 here. 5 raised to k plus 1 minus 1. So what could we do to show that this is divisible by 4? As much as possible, if you don't have a clue how to do this, you should look at our inductive hypothesis. So somehow we should show that 5 raised to k minus 1 is divisible by 4. I mean, this should appear somewhere. So let's try that. How do we do that? So let's manipulate 5 raised to k plus 1. So let me copy paste that here. So 5 raised to k plus 1 can be rewritten as, we could factor out a 5 from 5 raised to k plus 1. So something like this, 5 times 5 raised to k. So 5 times 5 raised to k is equivalent to 5 raised to k plus 1. And then, let me just copy paste it again. What we could do here is, how about we manipulate 5 here? So instead of 5, we write 4 plus 1. So 4 plus 1, the quantity 4 plus 1 times 5 raised to k. And then we multiply 5 raised to k to 4 and 5 raised to k to 1. So let's do that. So let's copy paste that here. So Um, let's remove this. Let's first erase this. So let's, oops. Okay, there. That's the first term. 5 raised to k times 4. 4 times 5 raised to k. Plus 1 times 5 raised to k. Or simply 5 raised to k. 5 raised to k. And then our minus 1. Okay. Now, as you could see, 5 raised to k minus 1 is our inductive hypothesis. We assumed that 5 raised to k minus 1 is divisible by 4. So we now know that this part here in our expression is divisible by 4. How about the other part of our expression? Is 4 times 5 raised to k divisible by 4? Obviously, yes, because we have a factor of 4 here. So a number that is divisible by 4 plus a number that is also divisible by 4 is a number that is divisible by 4. So something like our previous example, even number plus even number is also an even number. That means p of k plus 1 is divisible by 4. Therefore, our theorem is true. Or therefore, the theorem is true. So that's the answer via mathematical induction.